So, yesterday we reviewed a little bit of what our sine and cosine functions look like, which I've already graphed up on the board for us. Not the best drawings in the world, however it will do for what we need to do today. Okay? Which is to try and find the derivative of our sine and cosine functions. Now, we already covered sine of x, but I'm going to do this again for the recording just in case. When we're finding the derivative, it's probably going to do that again. When we find the derivative, what are we actually finding?
Tangent.
We're finding the slope of the tangent. Okay, we're tracking the values of the slope of the tangent as it goes around a function. All right. Now, where do we know the values of our tangents? At the min to max, the tangents are horizontal. So, what is that value then?
0.
0. So I'm just going to start with sine and we'll redo it again for cosine. So we know the tangent is 0 at pi on 2, 3 pi on 2, and 5 pi on 2. We know it is here, here. I guess crosses might work a little bit better. We know it's 0 there. What we kind of need to understand is what happens in between. Now I'll give you a small tip to begin with, just like we did last lesson. At this point here, right, the slope is going to be 1. Right, so it starts at 1, and now we need to kind of understand how this tangent moves. This is only an informal proof. There's other ways you can do it. One's in your book. Actually, both might be in your book. One goes through limits, all right, and the other one goes through first principles kind of stuff. We're just going to look at the shape and be like, yeah, that's okay. We'll live with that. So, our tangent starts with 1, and as we go up, tangent's going to get shallower and shallower, which means it's getting smaller and smaller until it gets to 0. All right? So we're getting smaller and smaller until we get to 0. When it gets to 0, what happens is it starts to tilt up the other way. So we have tangents going downhill. Yeah? Downhill means it's dipped into what territory? It's now negative, okay? Starts off at 0, goes a little bit negative, increases until it gets to here, which is going to be your -1. So it's increasing until it gets to -1. Then it starts to turn around again a bit. Starts to get shallower until it gets to 0. So as it gets shallower, the slope is getting closer to 0 and decreasing. A smaller negative number going back towards 0. And then we're back to positive, aren't we? Alright? Going back to positive, it's going to get to a 1 again at the 2 pi, which is a repeat of what's over here, yeah? So, gets up to about here, and it's just going to repeat that cycle again, isn't it? This part of our function is the same as this part of our function, right? Sine is periodical, it repeats after 2 pi. Yeah? So, that should dip back again. Now, what does this function look like to us? Cool. So we've covered that so far. Alright? So, this part here is important. Derivative of sine of x is equal to cosine of x. Now, can we repeat the same idea because of x?
Yeah.
Alright. So let's pick out our zeros. We've got horizontal, horizontal, horizontal. So it's 0 at here, 0 at pi, and 0 at 2 pi. But from 0, what's happening? We're going into what territory?
Negative.
We're going negative first, alright? Until it gets to half pi, where it is negative 1, guys. Negative 1, okay, 0 is horizontal. Anything in between is positive or negative. So, positive slope, alright, going up like this, negative slope going down like this. Smaller negative slope looks like that. Smaller positive slope looks like that. So, it starts off a little bit negative until it gets to negative 1 here. And then it dips again. It gets, from negative 1, it starts to get smaller again. So it increases until it gets to negative 1. What's up?
How do you know it starts at that point?
It starts at 0
Yeah, how do you finish it?
because it's a horizontal at the top here. So it has to start at 0. Yeah?
What about for the sine graph?
There's a sine graph?
So how do you know it starts at 1?
I just told you.
No, for d dot dx.
Just to make the instructions slightly easier, I just let you know what it was ahead of time to make the shape take form a little bit better. We'll get to that stuff. Yeah, we don't need to find values in it just yet, just what the derivatives are. I mean, I could have just set it with a positive value, and I can get rid of the 1 and the negative 1. Alright, and then eventually we'd get the same shape, but just to get quicker to that shape, I just gave you what it was. Does that make sense? So, I could do the same thing here, without the 1 and negative 1. In fact, why not? Now I've erased it. Starts off at 0, gets negative, and then it gets smaller negative back to 0. Yeah? 0, big negative, smaller negative back to 0. So, getting bigger, more negative, then it stops, gets less negative, and it goes back to 0. Yeah, that's what's happening.
Okay.
Do you agree?
Yeah.
Should I draw in the lines a little bit more? So, here it's 0. Yeah. Tangent here, it's kind of hard to draw a tangent through a point like that, but looks a little bit like this. That's quite a bit negative, right?
Yeah.
But down here, it's less negative.
Yeah.
Yeah? So you're okay with this shape
Mhm.
taking form, more negative, then back to less negative,
Okay.
and then it goes back to 0.
Yep.
Yeah? That's what we've drawn. Do you agree?
Yeah.
Cool. Khalil?
No.
No?
I don't. So it's more negative, and
Less negative.
why does it go? Because it's changing from more negative to less negative, so it goes back up.
Yeah.
That,
But it goes back to 0.
It's got to get back to 0, but here is shallower than here. Yeah? So a shallower curve means a smaller value.
So it's slow.
So it starts off small, really shallow up here, small negative, increasing negative, then back to decreasing negative until I get back to 0. So, increasing negative, decreasing negative until it gets back to 0.
Yeah.
Alright, and then go back to positive. Alright, so now that I've gone like this, I've got a positive slope. It's a small positive to begin with. Alright, so it doesn't jump. It goes from small 0, small positive, big positive. Right about here is what we call an inflection point. Alright, then it starts to turn the other way again. Alright, so big positive, and then it gets shallower, 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 smaller negative, smaller positive, until it gets back to 0. So it's bigger positive, turns around, so it goes back down to 0. And then it starts doing the same thing again. Alright. So, we can keep repeating that pattern if you wanted, but what does this shape seem like it's taking on now?
Negative sign.
Negative sign.
Excellent. So this is our other new rule. Alright. Again, there's more formal proofs in your book, which you can take a look at sometime soon. At the moment, I just want us to get those 2 rules down. How are we feeling about that? Yeah? So the negative sign, just in case people can't see it, alright, is when you times something by a negative, if you're looking at your sine function up here, everything positive is going to become negative, so it would flip down this way. And then everything positive would become, everything negative would become positive. So then it flips it in the x-axis. Mirrors it. So, that's it for now. We're going to be able to use those rules with product, quotient, and chain rule to get a couple more things. Alright, I'm going to stop the recording.